Welcome back to another game development video. When we last left off, we were talking about the animator window and the mecAnim system, and we imported a model and built a little framework for that model to change its animation based off of input. So now we need to start moving this character around, and in order to do that, we're going to need to get this character involved in the physics system. And just like we did in 2D, we're going to do this in 3D, but instead of physics 2D, we're going to go into physics, and we're going to add a rigid body, and we're going to go into physics again and use a capsule collider. Okay, let's fix this capsule collider so that it looks so that it fits our character a little bit better. The scale of our character is very small, so that's why we have to use really small values in order to get this to look correct. You could also scale the character up and not have to use such small numbers, but it's the same thing either way. There we go. Something along those lines looks just about right. Our feet might actually fall into the floor a little bit, but let's see. And of course, since now it's part of the physics system, gravity takes over and drops us down to the ground. So let's go ahead and create something for us to stand on. We're going to create a terrain. And let's make this terrain much, much smaller. And let's move it so that the character's got plenty of space to walk around. And now if we hit play, you'll see that the character has now fallen and landed on the ground. Easy peasy. And just like we thought, our feet are sticking into the floor. That's just because of our capsule collider. That's perfectly fine. It's easy enough to fix. There we go. That looks great. Well, that's all well and good, but the main problem here is that we're part of the physics system, but we're still not walking anywhere. We're going to change this by going into the script. And the script is just like we remembered. And in here in this update, I'm just going to put all this code in update, and part of the assignment for you is going to be to clean this up and put this in the correct implementation for that state machine. So let's walk through just some of the instructions here that you're going to have to go through in order to get this character moving in 3D space. Okay, first thing that I want to be able to do is rotate according to my horizontal input. And we're going to use the transform.rotate function for this, and the transform.rotate function has 6 different versions of it. We're going to use the 5th version here, which takes in 3 float values for each axis that you want to rotate on. We don't want to do any rotation on the X or Z axes, so we're going to pass in 0 for the X and the Z. For the Y, we actually want to pass in our horizontal input here. So this is going to be the value of either 0 if there's no input, or 1 if we're trying to move right, or -1 if we're trying to move left. And so if we keep rotating with -1 or 1 every frame, then that will generate a rotation, a smooth rotation for our character. You'll see that once we actually get back to testing. Actually, I think I can just test that now. It may be very slow. Oh, nope, not as slow as I thought it would be. But there I'm holding down the D key, which is how we're moving right, and that's comical. You see that because we're using a rigid body, I always forget about this, you can knock your rigid body over. Let's see if I can do it one more time. Yeah, there he goes. Okay, cool. All you need to do to fix that is freeze the rotation. Huzzah! But there you can see that transform .rotate call is responsible for us rotating. Okay. The next thing is we need to generate a direction that we want to move in. There's a lot of different ways that you can do this. So the way that I'm going to show you is not necessarily the correct way. It takes a lot of research and a lot of practice to create very complex, character movement systems in 3D. I'm going to show you a pretty direct approach that makes a lot of sense to me, and I think will be intuitive for you. But don't necessarily take this as the gospel of this is how to do this. For example, for my character that we're making here, we're going to use the character's own forward vector to move along. There might be other games, like games that have like a static camera, where you would want the character to move relative to the camera's forward vector instead of the character's forward vector, and that will drastically change the way that it behaves. If you're using the camera's forward vector as a reference for moving left and right and trying to move around, then whenever you're trying to move, whenever you hit the W key, you will always move up in perspective of the camera. If you're using the character's own forward vector for movement, when you hit the W key, you'll move in the direction that you are facing, those are two very different control mechanisms. So I just want to make sure that it's clear that I'm just going to show you one way, but there's several other ways to do this. In order to generate a direction, I'm going to create a new vector, and I'm going to call that target direction. And I'm going to set that equal to our transforms forward vector, because like I said before, for my character, whenever I hit the W key, I wanted to just move forward in the direction that I was facing. So I'm going to use the forward vector, but here's where I'm going to use that vertical input information. I'm going to multiply the forward vector by that vertical input information. So again, this is going to be -1, 0, or 1. If we are not trying to move, forward into the screen, or forward in the direction that the character is facing, then it's going to be 0, and then we're going to take our transform.forward vector and multiply by 0, which means that our target direction is 0, and we won't move anywhere. If it's -1 or 1, 1 means that we're moving forward in terms of the direction that I'm facing, and then if we multiply by -1, obviously that means that we're trying to move backwards, along that forward vector flipped 180 degrees. Okay, now once we have our target direction, the next thing that we need to know is how fast we want to be moving along that forward vector, that target direction. So we're going to create another vector. We're going to call this target velocity. And we're going to set this equal to our target direction times a scalar factor, which is going to be our speed. Let's create a new member variable for this, and let's call this float private speed. And we'll just set it to a default of 1.0f for now. So our target velocity is going to be equal to our direction times speed. So it's going to amplify the magnitude of that vector. And then finally, we want to know how much is our velocity changing based upon last frame's velocity and what our target velocity is. So if something weird happens and our velocity spikes for whatever reason, maybe we went near an explosion, and the way that the physics system calculated something, it gives you some really wonky, crazy velocity. We want to know within one frame how much does velocity change, and put a cap on it, so that we don't within one frame accidentally get like 1,000 units per frame move in that direction. We want to put a cap on that velocity change to maintain a consistent behavior. That's what this delta velocity is going to be for, and in order to gauge that, we're going to use our target velocity and subtract our rigid body's current velocity. So again, here's where we're going to need to clamp those values. We want to clamp specifically the x and the z values. That's what's going to control our horizontal and z-axis movement as well. So we're going to set our x for that delta velocity vector that we just created equal to a mathf.clamp operation. And we're going to be passing in the delta velocity.x, and then for the minimum and maximum values, I think I want to create another variable over here. So let's create a new variable, and we're going to call this not calling it that. Stop doing that. There we go. We're going to call this our max delta vel. Yes. And I'm just going to try out 10.0f and see how that goes. And now back to our clamp operation over here, we're going to set the delta velocity.x, and we're going to clamp it to negative max delta vel. Let's see, did I do that correctly? Okay, there it is. Alrighty, so we're going to clamp the delta, the change of velocity. So basically, how much we're going to change. This is very similar to what we were doing in the 2D project. Whenever we were just checking the boundaries to make sure that our velocity didn't get out of control or be beyond our max speed. So this is just checking to see, how putting a maximum on how much it changes from one frame to the next. So from negative max delta vel to max delta vel, and then we're going to do the exact same thing on the z-axis. These stay the same. Make sure that the y remains at 0. For just walking around, I don't need to worry about any change in velocity on the y. If I was doing a jump state or something along those lines, then we certainly would need to concern ourselves with our y velocity and our change of y velocity from one frame to the next. Finally, now that we've done all of these things, we want to apply this to the rigid body. So in the 2D experiment, we did that by modifying the velocity variable directly. However, we also could have used the add force function. So I'm going to use that now. And we're going to pass in the delta velocity. And then the add force function, if you watched the little video snippet that I included in the experiment, the add force function also has a force mode that you can specify. And so for this one, we're going to use velocity change. And so it's effectively the same thing pretty much, but doing it within their framework I think is even better. So this is what I would recommend in terms of how you are manipulating the velocity directly. So you could even go back to the 2D project and retrofit it to use rigid body.add force with the force mode velocity change, and the behavior is pretty much the same. Okay, so we've done a lot of things here. Let's just make sure you've got a target direction, which is using our transforms forward vector. We've got a velocity, which is our direction amplified by speed. And then our change in velocity is our target velocity minus our current velocity. Clamp it, add it. Let's see what happens when we switch back over to the editor. Oh, and look at that. We've got a character moving. Notice how hitting left and right does not apply any movement. If you would want it to, you would need to implement it in that fashion. This is just a very, very bare bones, simple movement system, and one that I think makes it easy to understand the purpose of like vectors, like your forward vector, and moving along that as opposed to the camera's forward vector and things of that nature. Okay, so that pretty much does it for just showing you how to move like objects in 3D. Obviously, you're going to need to clean this up and move it into its own state behavior logic. So I'll leave that for you to clean up because we definitely don't want to be doing all of these things in update. So that's part of the assignment. If it shows up in update, you can expect to be basically to not get any credit. If you're putting this much code in update, it compromises the state machine. So make sure that you clean this up, refactor it, put it into helper functions, and distribute those functions amongst your different states that need it. Now, once you start adding more states and you start adding things like a jump, for example, that's when we're going to have to come back here, and we're going to need to tell the animator controller how to transition from the locomotion state to any other state. And we're going to do that using transitions. Now, I'm not going to hook up any other animations because it's part of the assignment to do that, but I'll show you how to set up a new state and how to set up a transition. So let's create a new state, And here's where you can attach an animation if you have some. So let's see here. Let's just take the death forward, and let's call this the death state. So that's how you generate a new state. Don't worry about the fact that it's gray. That's fine. Remember, the orange one is the default state, meaning that when this object begins, this is the state that it will begin with. So now what you need to do is tell it how to transition from one to the other. And you right-click on any state. If you have to right-click on a state. If you don't click on the state itself, you won't get this option, but you have this make transition, and now you've got this line that's attached to your mouse cursor. Just click on the state that you want to make a transition to, and it will snap in place. This is an object all on its own. It has options in the inspector. So this is what you'll be working with a lot of the times. So in the inspector, down here you're going to see conditions. By default, the condition is just that the animation is done playing. But you can change the condition to be something else. For example, let's say that we added a parameter for in air. Then you could use the in air variable and say, if this was not the death state, if this was actually, the jump state or something like that, you could set a boolean along those lines and then go back to the transition. And if in air is true, we would transition to jump. And then from jump, we would need to make a transition back to locomotion when in air was equal to false. Now, if this was actually the death state like I originally intended, then actually we probably don't want to use a boolean. I probably just want to use an integer for health. And now we can change this to see if health ever becomes less than 1, then we know that we're dead. And then for the transition back, this could be something else like, do we restart the did the player hit like continue or something along those lines? There could be a separate parameter for transitioning from the jump state back to something else. Or I imagine that the game would actually just reload the level. And that the death state might just be the final state for that particular object. But now you know how to add a new state. There's a lot of information on the Unity site. There's a lot of videos for the mecAnim system. I highly recommend that you find those and watch those so you can get even more information about how the system works. It's really, really cool, and Unity's throwing a lot of weight behind this system. Okay, and that pretty much wraps things up here. We have added a new state to our animator, and I've explained how you can make transitions and how you can base those transitions off of different exit conditions. I've directed you towards other Unity resources that explain the mecAnim system in even more detail, which I can't recommend enough. And we also added a rigid body, a terrain, a capsule collider, and we also added code to move our character in 3D. Remember, it's your job to sort that out into state machines. But otherwise, the only other thing that's left to do is to attach a camera to this, and there's going to be a separate video that explains the camera follow script. So thank you so much for watching, and make sure that you hold on to this video, save a link somewhere, in case you ever need to reference this back again when you are getting more curious about 3D movement and things of that nature. You can use this as a refresher.